Hello, welcome to Flipped. So today we are in transition elements, and transition elements are a very unique category of elements which are found between group 2 and group 3. Okay, so this yellow box here, they are all transition elements, and they have high density and high melting point. Okay, what do I mean? High density means they sink, okay, in water, whereas high melting point means high temperature required to melt them. Okay, and at the first glance you may say that, oh, these are just metal properties, and you are right. Okay, metal have these two properties, but what separates transition elements from metals, okay, is what we'll be discussing in the below section. Okay, so as a recap, okay, transition metals do not belong in any group, and they only belong in this box here. Okay, that does not have any headings. Okay, now we will talk about the difference between transition elements and metals. What actually separates metals from transition elements is really just two properties. Okay, first one is that they can form variable. They have variable oxidation state. And what do I mean? It means that they can form more than one oxidation state. For example, iron. Okay, this is iron, Fe. Okay, can actually form Fe2 plus and Fe3 plus. Okay, this is quite weird compared to what we have learned so far, right? For example, we know that, okay, we have sodium, okay, is in group 1, so it has to only form sodium plus. For example, magnesium is in group 2, so it only can form magnesium 2 plus, Mg2 plus. Okay, it cannot form Mg3 plus, and neither can Na form Na2 plus or Na3 plus, for example. But in the case of transition metals, they are very unique because Fe, for example, can form 2 plus and 3 plus. Okay, so they have more than one oxidation state. And what's the significance of this is that when you have multiple oxidation states, okay, you can be 2 plus or 3 plus, you can form more than one compound with the same element. Okay, for example, with OH, okay, Fe2 plus forms OH, okay, forms FeOH2 with OH minus, and Fe3 plus forms FeOH3 with OH minus. So this is a very significant difference, okay, because one atom breaks into can form two different cations, which can form two different compounds. Okay, this is very useful for us. So what's the second difference between metals and transition elements is that transition elements can form colored compounds. Okay, we learned that group 1, okay, and group 2, okay, they just form silvery silvery metals, am I right? Okay, they usually form silvery compounds, okay, salts, or either they can dissolve in water, etc. Okay, but this is not the case for transition elements because they form colored solution. Okay, we can see here, for example, Fe, okay, iron forms Fe2 plus and 3 plus. We have established that here. Okay, so the oxidation state is plus 2 and plus 3. So this is something that people are confused. So in ion, cation state, this is 2 then plus. Oxidation state, you have to flip it around. It's called plus 2 and not 2 plus. Okay, hopefully that doesn't confuse you. And Fe2 plus, okay, with oxidation state of plus 2, has a dirty green color. Okay, means it's like a dark green. And for example, what compound it can form with OH minus can form FeOH2. On the other hand, Fe3 plus can form can have oxidation state of 3 plus, and its color is reddish brown. Okay, and it can form FeOH3, for example. Next, we'll talk about chromium. Okay, chromium can actually form 3 plus and 6 plus, which in the case of oxidation state is plus 3 and plus 6. Okay, this is very important. Okay, don't confuse 3 plus with plus 3. Depends on what you're looking at. Okay, if it's attached to element, okay, symbol, it has to be number first, then plus. If it's just asking you to state the oxidation state, it's plus then the number. Okay, hopefully that's clear. So 3 plus has an oxidation state of plus 3, is green in color. For example, it can form CrO3 with oxide ion. Okay, then Cr6 plus can form oxidation state of plus 6, which is orange in color. It can form this K2CrO7, okay, which is formed between Cr6+ and K+ and oxide ion. So finally, we have an example of copper. Okay, copper can form copper plus and copper 2+. So you see that my copper plus, although it's +1+, I don't write the 1 here. Okay, but I have to write a +1 in the oxidation state here. Okay, it's black in color, and for example, copper oxide. Copper 2+, it's +2 oxidation state. It's blue in color and can form copper hydroxide. Okay, and these are the two differences between transition elements and metals. Okay, although transition elements are usually metal, okay, they look metal, but the main thing is that transition elements have variable oxidation state and they form colored compounds. These are two things that normal metals, okay, for example in group 1 and group 2 cannot do. Okay, they are forced to only form one type of cation. Okay, hopefully that is clear for transition elements.